Hi, Geometry. Welcome to 11.6 Volumes of Prisms and Cylinders. I haven't done a video in like 3 weeks, so now hopefully I can finish up this chapter today and start with chapter 12. Alright, here we go. I can find volumes of prisms and cylinders. I can use that also in real life. So these are our learning targets, and this is what we hope to apply. And what's one nice thing is there's just one basic main formula, but we have to adjust it for different shapes. Here we go. Find the area of each polygon or a circle. Okay, so trapezoid. If you recall, a trapezoid kind of looks like this. You have one set of parallel lines, and those two are called the bases. And our bases are 12 and 18. Then the height. Okay, the height is the right angle distance between the two bases. I don't want that to be really dark, so that's going to be 3. The formula is area is equal to 1/2 your height times your 2 bases added. This is such an important formula. You have to remember this when you get to calculus. Of course, you probably don't need a lot of it until then, but you need it in calculus. Algebra 2, you may or may not be covering this. So here we go. So I have 1/2, the height is 3, and the 2 bases will be 12 plus 18. Well, 12 plus 18 is 30. So then I have 1/2 times 3 times 30. Well, I know 3 times 30 is 90. Half of that is 45. I wonder why this is not really dark. And that would be feet squared. That's our area. It's a little better, but then we lose everything else. Oh, it's adjusting. All right, circle. If you remember for a circle, this is our diameter, which is 8.2. What about our radius? Our radius is going to go half. That's going to be 4.1. The formula is pi r squared. So I have pi 4.1 squared. I mean, technically that's a correct answer, but let's put it in the calculator. Look at that. We have a cardioid shown. I don't know if you can see it. Alright, so I have 4.1 squared, there you go, times pi. Second pi, you see that? It's equal to about 52.81 inches squared. Okay, regular hexagon. So, remember what regular means. All sides are the same, and all your angles are the same. Well, let's just look at one of the triangles. Hexagon's picked for a reason, because the hexagon, this is going to be a 60, 60, 60. It's an equilateral triangle. And then if I cut it in half, I now have a 30, 60, 90. Okay, and they tell us the side length is 14, so this whole length is 14, but I cut it in half, so this is going to be 7. Now, I don't know if you recall, you have x, 2x, x square root of 3. Well, if x is equal to 7, this is 14, and this is 7 times the square root of 3. So what's the area of one of these triangles? Okay, so the area of one triangle is 1/2 base times height. But I have how many of these triangles? 6. So I'm going to take, so the area of 6 triangles will be 6 times 1/2. The whole base is 14. And the height is 7 times the square root of 3. Okay, put all of that in the calculator. Please double check for me. You get about 509.22 centimeters squared. Alright, keep in mind these are all areas, so they're unit squared. We will be doing volumes, so it'll be unit cubed. Alright, here we go. The volume of a cube postulate. So if you have a cube, and this is the length, this is the length, and this is the length, it's just length cubed. Can you see that? It's really hard, crazy glares. Alright, or you could just say length times width times height. Well, if two polyhedra are congruent, then they have the same volume. Oh, that makes sense. if here, if this is 3 by 3 by 3, and this was 3 by 3 by 3, they'll have the same volume. Volume addition postulate. The volume of a solid is the sum of all volumes of all of its non-overlapping parts. Okay, so don't count the same block twice. So let's look at this one. This one definitely pertains to postulate 29. So I'm going to use some colors here. Let's find the volume of the puzzle. So let's find these. Oh, this is 3 by 5 by 4. So that means each segment is worth 1 by 1 by 1. So here, if I count just these blocks right here in red, let's think about it. How many do I have? I have 1 by 1, 2, 3, 4 by 1, 2, 3, 4, 5. So that's 20. And now in blue, let's do these. I'm trying to keep it organized. It's 2 by 4 by 1, so that would be 8. And then maybe in green, let's do these. Alright, so it's 2 by 2 by, actually, let's be careful. 3 blocks here, 3 blocks on this one, 3 blocks on that one. Yeah, it wasn't 2 by 2, it was 2 by 1 by 3. It's supposed to be 9 though. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to be 9, so be very careful. Got to make sure you're not missing one. I kept missing that stack in the back. Alright, how about purple? Purple, let's do all of these. Maybe these blocks. Alright, so I have 2, 4, 6, 8. There's 8 for those. And then in pink, this one by himself. Add them up. So we have 20, let's see here. This is 10, plus 20 is 30, plus 16 is 46. 46 centimeters cubed. Can you see all that? I think coloring it made it easier. Alright, moving on. Moving on. Here comes the good stuff. Ooh. Prisms. Okay. Well, naturally, you don't see that picture very well, but we'll try to figure it out. The volume of any right prism or right cylinder can be found by multiplying the area of its base times its height. So, for instance, if you find the area of this base, multiply by the height, you have your answer. And I like to call this volume, excuse me, is big B times h. Well, big B is the area of the base. This base is a circle. So the area of a circle is pi r squared. So this will be pi r squared times h. And how about prism? Big B, like this is our base, times how high it is. So big B times h. Okay? And just so happens, this would be length times width, and then how high it is. 8. Okay? Now, here is a pentagonal, because there's 1, 2, 3, 4, 5 sides. Pentagonal prism. So here's our base. You can't even see that. It's so dark. In the original color, it looks kind of cool. So this is what it looks like in the original color. So, yeah, the purple base, and how high it is, h. How about this? A triangular prism. I might have to draw this in. So here's my base, right here. And stretch it out times the height. Okay, it just so happens volume is big B times h, but area of a triangle is 1/2 base times height. That would be the height of this triangle, then times that other height, how long that prism stretches out. So that one's always kind of weird. But this is also why they like to use just big B times h. Here, big B times h. Any questions? Like I can respond. So let's find the volume of these two solids. Okay. Again, volume is big B times h. And in this case, pi r squared h. So I have pi, my r is 40, the radius is 40, squared times how tall it is. 10. Well, I know that 4 squared is 16. Add 2 zeros. Add another 0 with a pi. Whoa, look at that. I have 2 sets of equal signs there. And if I were to put that in the calculator, you may or may not be able to see this, but I'm just going to go ahead. You get about 50,265. .48. Don't forget the units. Inches cubed. Do you see that? Alright, so now this one, area of the base. So big B is equal to 1/2 15 times 8. Well, half of 8 is 4. 15 times 4 is 60. So remember, volume is big B times h, so I have 60 times 12. Well, I know that 6 times 12 is 72. Add a 0. Centimeters cubed. Alright, so far so good. The volume of the box, in case you want to know, has to be 108 inches cubed. Maybe you're filling it up with jelly beans. So find the dimensions. So what size should the box be? Now, it's a box cube, so that means I know it's x times x times x. So here volume is equal to just x cubed. That is big B, x times the height. So here we go. And this has to equal 108. But I need to get x by itself. So how do I get x by itself? Cube root to both sides. So those will cancel. Okay, now, I don't know if you know how to find the cube root here. So if you press math, let's see, you can't see it. Let's turn this off. Still can't see it. Made it worse. Alright, you can kind of see, if I go down to this one, that's the cubed root. There's a 3 there. In any case, press that, enter, and then type in the number 108. You get 4.76. Because this is not the volume, this is just the length of one side, just inches. Alright, Cavalari's principle. Not much you could do with this, except if you take your prism of any type and kind of tilt it like the Leaning Tower of Pisa, the cross-section will still be the same. Alright, so if two solids have the same height and the same cross-sectional area, then you'll have the same volume. Alright, so if you look at these two, find the volume of the oblique cylinder, well, it's going to be the same. They have the same height, they have the same radius. Just because it's leaning doesn't mean anything. So volume is equal to big B times h. Big B here will be pi r squared times h. So r is 2, h is 4, 2 squared is 4. I'm going to get 16 pi. Okay, so that's your exact answer. But if you put in the calculator, it's about 50.265 inches cubed. A cistern is a large tank used to collect rainwater. It is made of concrete 3 inches thick and is open at the top. Find the volume of the concrete needed to make the sides and the bottom of the cistern. Okay, so here we go. We know that, let's do the volume of the whole thing, and then let's do the volume of this and subtract them. Should be interesting. You know, I'm almost worried if I have the wrong answer, and I'll explain why. Alright, so we know big B times h, and we're going to do the whole thing. Alright, so keep in mind, for the whole thing, from here all the way to the edge, that's 18. So that's pi 18 squared times 20. And you put that in the calculator, you get about 20,357.52. So now let's do the inside. Alright, so you get, now keep in mind this is 3 inches thick. I just want to find the inside. I'm taking it out. So if I take 18 minus 3, I get 15. So 15 squared, forgot the pi, and that height is now going to be 17. Why? Because the whole thing's 20, but we're going to keep 3 inches on the bottom. Oh, this is going to work. Okay, never mind. Multiply that out, you get about 12,016.59. At first I was wondering if I took the bottom part out too, and I didn't. Okay, so take those two numbers and subtract. That's it. And when you subtract, you get 8,340.93 inches cubed. It's kind of a lot. In any case, here is our homework, and this is our Common Core standards. Use volume formulas for cylinders, pyramids, cones, and spheres. Obviously, we haven't done the pyramids and cones yet, but that will be coming up. Everybody, have a nice evening.